Hi, Sandy.
Hello.
Hello, everyone.
Good afternoon.
Hello, everyone.
Roland asked to be excused. He's got a other thing he needs to wrap up.
I think as long as one of you is here, it'll be fine. Hello, Matt.
Good morning from Seattle.
Hey, man.
Good day.
Let's give that a couple more minutes. At the moment, we have 80% our team and 10% a system integrator, 20%. Well, the ratio is probably even worse than that. Like 1 to 8. You're outnumbered, Foley.
Oh, well.
Skip ahead to our antitrust policy, which by now everybody would be well familiar with. This is the Linux Foundation. Meetings involve participation by industry competitors, and it is the intention of the Linux Foundation to conduct all of its activities in accordance with applicable antitrust and competition laws. It is therefore extremely important that attendees adhere to the meeting agendas and be aware of and not participate in any activities that are prohibited under applicable US, state, federal, or foreign antitrust and competition laws. If in doubt, please contact your lawyer. Hello, Ame. Our system integrator complement is almost up to 20%.
Yay.
Right. So maybe just quickly reviewing the agenda for today. We're going to just go through a little bit of the working group feedback, and we're not actually going to be doing feedback today, but we are just going to give you an update on the 2 working groups that are currently in play. We're going to be winding those down in favor of a slightly more alternative approach. We've done a lot of work in those already, so we'll be talking about that in a minute. And then we just want to show you some of the work that we are proposing to do as part of our upcoming features expansion or implementation around dynamic data ingestion. So this is a change that we are proposing to the architecture, and we are sending out a document for comment. So I'm going to be walking you through the basics of the dynamic data ingestion approach, and then you'll be receiving a link to the document on our Google Drive. And if you would like to review it and leave any comments, please do so. And then we can come back in a future session and review your comments as part of the group in the community. Okay. Pressing on. So what we're going to be doing with both of these, the community participation started strong, and I think we spent quite a lot of time outlining a lot of the work that needed to be done. And then when it came to commissioning some of that work for community participation, our participation kind of dwindled a little bit. So we don't want to keep on hosting the sessions for only 1 or 2 people to show up every week. I think it's quite a lot of time that people are sacrificing to participate, and we appreciate that. But what we want to do is to maybe just change the pattern for participation a little bit. So what we're doing is we're converting a lot of the work into GitHub issues, and I think a lot of those GitHub issues have already been created, and then commission that work to the community. So all of our issues are published in GitHub anyway. So if you want work, if you are want to contribute in a particular way, there are issues that you can pick up and then contribute to. And that applies to both the expansion of the contribution guide, and then also the CI/CD work that Scott has been leading, and the contribution guide obviously being led by Sandy. And then we are going to close out the working groups themselves. So unless there is a need for a discussion around some of those, if anybody needs a feature or some conversation needs to be had about a proposed execution on one of these tickets, then we will discuss that here in the technical steering committee. But for the moment, then those issues would live by themselves and be available for voluntary contribution. What we would like to do, though, is as we commission these, part of that commissioning process would actually be just a walkthrough of the issues here in the TSC. So both for Sandy and Scott, we are going to make some time available in a future TSC just to walk through the list of issues and show everybody where those issues are and how those issues can be picked up and contributed to by the community. And then that's it. The issues will be for the community, by the community. So we'll do that in a future TSC session. So in the next couple of weeks, both Sandy and Scott are going to take turns to prepare for their commissioning of the work into the community. Quick pause. Any questions from anyone? Excellent. I love it when there are no questions. Okay. Carrying on then to the next item on the agenda, dynamic data ingestion. So some of you may have seen this diagram already. This is our expanded ecosystem for the Tazama fraud risk and money laundering risk, financial crime risk management system and framework. Well, basically an ecosystem. So currently what we have in the corner here is the Tazama transaction monitoring system, and that is our current existing functionality and our current existing system. We are proposing to build a number of functionalities around this. This is specifically for the Camisa implementation that is also coming up. So we are building some foundational components that will then be implemented first for Camisa, but will also be available as open source software for our community. And then one of the things that we typically have, not just for Camisa, but for most of our customers in general, is we have discovered that a lot of people actually need to integrate their existing transaction systems with the Tazama ecosystem in the first place. And it's not as straightforward as we always imagined. Our current interfaces are designed specifically for ISO 20022 connections and integration. But in our target market, there is still a decided lack of adoption for ISO 20022. There are a large number of institutions that are in fact still using ISO 8583. And beyond that, there are a number of bespoke integration message formats across the industry. And what we are finding is that when people try to implement Tazama, it's very difficult for them to run a POC. It is very difficult for them to actually do the integration because you need to go into our transaction monitoring service API and you need to modify the code. Or you need to create a payment platform adapter for your specific environment that can then translate your message format into Tazama's specific message format. And by itself, that may not be enough to cover all of your use cases and all of your requirements. So that is our current sort of environment, right? So you would have your existing system over here, your transaction monitoring system. And if you do not speak ISO 20022, or for example, if you are a Mojolib implementation, you would submit your messages in the native format. So for example, a quote request, a quote response, a transfer request, and a transfer response. And then inside the payment platform adapter, there would be a transformation step that converts those messages into our ISO 20022 messages. And then you would submit that ISO 20022 message into the system. And our interfaces here are built around JSON. So you would submit a JSON message into a JSON message. And that's the payment platform adapter that we had already built as well. And then inside the system, there's almost like a single component here. So the transaction monitoring service API basically receives this message and then automatically converts it into the right format for the database, posts all of that information into the database, and then sends the payload onwards to the event director here via NATS so that that transaction can eventually be evaluated. Right? And we also have a administration API that does the configuration or the condition management. In the future, we also want to be able to surface configuration management onto that API. And then also there is a endpoint that allows you to query the result of a previous evaluation. Foley.
Yeah, sorry, I thought I would let you finish off, but just a comment. The PPA you've got as JSON to JSON, but it's not necessarily from JSON. We've built a couple of different payment platform adapters that the source is not JSON. So I'm not
And
sure.
XML as well, yes.
Well, or
even
anything else.
CSV. Yeah. Yeah.
Or a Kafka topic, like
yes,
with CDC or something like that. Yeah.
Yes, or even a Kafka topic. So the payment platform adapter has a number of options that it can sort of receive messages from. Yes, you are correct, right? So at the moment, what we want to be able to do is to create a software development kit or a utility or a tool that will allow you to build and deploy dynamic interfaces into a API that a client system can then utilize to be able to transact with Tazama, to be able to send messages in. What that first and foremost means is that we are probably here trading off a little bit of our performance in our ingestion capacity for accelerated deployment and accessibility, right? So we are saying that we want to be able to allow more people to be able to adopt Tazama much faster and much easier than having to do this through a code-based integration pattern, right? We want them to be able to configure an interface through which they can then transmit data into the Tazama system, which looks a little bit like this, right? So for this, you would have a number of different options, XML, CSV, or JSON files. And through what we call the data integration software development kit, you would create these interfaces through a user interface. And typically what that would look like is you would have your sample specification for the input file, you would drop that into a transformer, and you would do the mapping to Tazama's native database. Right, to be able to say, okay, cool. Any kind of message that I would like to be able to ingest in Tazama in the future, I want to be able to create this dynamic API endpoint for. And what that would also mean is that you would probably no longer need a payment platform adapter as a preface to the system. Normally, you actually would just surface your messages, your endpoints directly onto this API. But we don't want to interfere with somebody who prioritizes performance over acceleration necessarily. So if somebody still wants to be able to build a high performant version of Tazama, or they want to be able to build their own custom interfaces into Tazama, then they should be able to do that. So we are basically calling the current model here a static transaction monitoring service API, or in the future, an event monitoring service API. So the existing API, the TMS API, will still exist. If you want high speed, high performance, then you will fork that API and you will build your own interfaces directly into it, or you will continue to use the payment platform adapter pattern. But if you are a small organization and you just want to be able to do your few transactions by yourself, and you want an easy way to adopt the system and roll the system out, then you would use the data integration SDK, right? And the data integration SDK would basically create endpoints for you that can be deployed dynamically. And that is something that we have proofed already to a certain extent to make sure that it works. So you can basically deploy these interfaces into a dynamic sort of a host API framework, and then you can access or interact with those APIs from outside the system. And those APIs can also accept sort of JSON documents. It can accept XML documents. And also, in addition to that, there would be an API for evaluations. So if you want to evaluate the transactions that you're ingesting, you can do that. And we are calling that the Dynamic Event Monitoring Service, the DEMS API. And then alongside it, we want to be able to create an API where you can add enrichment data into the system much easier. So with a data integration software development kit, both of these are now possible and equally easy. So if I want to be able to add lists of information into the system that I can then later reference in a rule, or if I want to be able to add information from another system, whatever kind of additional information, like for example, in the past we had a problem where if you wanted to ingest country-based IP address mapping information, right? That is information that needs to be ingested separately and then hosted inside tables inside Tazama. You'll be able to do that through this dynamic enrichment API in exactly the same way. And creating a scheduler with a cron job that can even go and fetch that information in according to the schedule that you set up. So on a daily basis, for example, you can go get a fresh list, and that list can be then uploaded into the system and then can be used for evaluations in rules inside the system later. Pause for questions or applause or boos. Is everybody wanting to see where this ends up before they make any comments? Foley.
No, I thought I'd wait for the hopefully next slide, that's more technical. That's going to show how this is going to happen, and because that's where my questions would be.
Technically, I am probably not the person who's going to be able to explain it to you. We should probably do that for a follow-up session. But what we are going to be trying to do here is cover the requirement and sort of the product approach to the problem. But we can certainly arrange a slightly more detailed technical review of at least the POC that we did, so that we could show you how this would work in practice as well. I think that would be quite interesting. So we'll put that on the agenda for the next TSC. But what we do want to do is to give you an opportunity also to review the document and then let us know if there's anything in particular that you think we might have missed in our requirements or in our sort of design. Right, but now, right? So there are two kinds of ingestion approaches, and I've mentioned these already. There is the ingestion for evaluation. Did I mix up these two pictures? I think I may have put them the wrong way around. I might have. So in our current environment, what is actually happening is you have an endpoint, a fixed endpoint, and that endpoint validates the message. The message is decomposed into specific message fragments that we then use later in the system for evaluation purposes or to be able to post stuff into the database. We are mapping those message contents into a cache because we manage some sort of message, inter-message context via the cache as well. And then we update our data stores, and those data stores are sitting here in ArangoDB. We compose a payload, which is then the payload that we are going to be evaluating downstream. And then we encode that message via protobuf and then transmit it via NATs, right? Foley, did I cover all the steps?
On a high level, yes, sounds about right, yeah.
Okay, perfect, right? So this is the approach that we are currently following for ingesting a message into the system. And when we are looking at each of these steps are actually possibly configurable, right? So we can turn the code that we are using currently to be able to execute each of these steps into something that we are able to configure through a user interface. So we can create a message that comes in. We can define that message specification when it is dropped into our interface. And we can carve out of that message the specific fragments that we need to be able to do our evaluation, or to be able to post things into the database to manage the mapping to our current data model. And then we can also just say some of this information needs to be cached periodically, and we create the keys and the patterns and everything that we need to be able to retrieve it from cache later. And updating our data stores a similar fashion. Some of those data fragments gets posted to specific sections in our database. So again, we are replicating behavior that we already have code for in our normal API. So we'll be replicating that and putting those sort of like building these together as Lego components inside a interface builder. The biggest problem here is around protobuf. And we'll talk about that in a little bit as well. That is a problem that we are currently stuck with, and we're trying to have to figure out how we are going to make that work. I think Foley would already know what the issue is, so we'll get to that slide in a few minutes, and we can talk about what we can possibly do to approach that problem. And then in the dynamic data ingestion for enrichment, which is this image here, it's very similar. You want to be able to do JSON, XML, or even batch files in CSV format, drop them into the interface, and then do a mapping that ends up in ArangoDB that creates data that you can then use later on when you want to create a rule to do that evaluation. So this is a little bit simpler because we're not trying to integrate this data into our existing data model. We are just trying to get this data into our database so that we can access that data for evaluation, right? So these are the interior steps inside each of these two different interfaces. So one of the challenges that it had, or one of the discussions we had here, was whether or not the software development kit should actually be deploying these interfaces directly into a production environment. But we ultimately decided that we would prefer to use the existing CI/CD and version control that is available already, rather than trying to create and manage our own source control and version control into our own application or in the SDK. So the SDK would have sort of interact. Typically what is currently happening is if I wanted to update something that I have code for already, that code comes out of our development environment. I turn that code into a feature branch. I upload that code back into GitHub as a new feature branch. If that feature branch is approved, it is then promoted into the new dev branch, and then ultimately that branch gets posted into the updated version of the system, which is the main branch. So that's our most recent production version of the system. So in theory, the interfaces that you're building here should follow the same process so that you can actually deploy that interface into a development environment that is for Tazama, and then promote that code module from the development environment to a test, QA, UAT, pre-prod, and prod environment. We don't want the SDK to post an interface directly into the prod environment, because we think that is risky, and we also don't want to be responsible for managing source and version control on our own. We don't want to reinvent a wheel here that already exists and something that GitHub is doing very well. Right. So this spider's web and mess of lines is effectively what the data translation currently looks like in the system. So if we are receiving, for example, a PAX 008 message, some of the elements of that message are being used and transformed in the system. So we believe that we would be able to follow the same process to allow a user to decompose the message and then perform transformations on certain part of those message and create new data from existing data in a sort of a visual way, and then be able to create code that can manage that in an automated way going forward. So if I'm deploying this interface should be able to fulfill all of these steps in the same way as I would have if I was a developer and I was writing all of this code by hand. The complicated interaction for us here is at some point in the process, we may be posting messages to a cache because in a future message, that message will be read back out of the cache. So for example, here, the PAX 008 message has some information that ends up over here. There's a cache key, and then our data cache object itself is being cached. So what we can then say is for this particular endpoint, these are all of the transformations and code fragments or message fragments that we are going to be using and the way that we are going to be using them. And we are building this particular workflow in a visual way. And you'll be able to do this for any kind of message that you are then ingesting. And then the next one up is if you're looking at the PAX 002 message, for example, that PAX 002 message also needs to be able to fetch information from the cache. So your user interface that you're using to build these endpoints needs to be able to traffic with the cache as if it is a data source as well, so that you can basically enrich this other message with information that is in the cache, where you are looking for a key that you had previously created in the cache. So again, this is functionality that exists in code at the moment. And what we want to be able to do is to lift it out of the code and convert it into a sort of a configurable user interface driven process where somebody can create a user interface that can mimic exactly what you would do if you were doing this in code, which would make it a lot easier for people to spin up and create new user interfaces for their particular environment without actually having to fork our transaction monitoring service API or implement a payment platform adapter that they then have to develop from scratch. A little bit about sort of the range of the data, right? So, and this speaks to the problem that I was talking about earlier, right? So when we are receiving information, as soon as that information hits the event director, that information is virtually indistinguishable from a message that comes from the TMS API, except that it's a new message in a different format. The system interrogates that message for its type and will then simply route that message according to that type to the appropriate rule processors and the typologies and so on. So as soon as a message gets to the event director, the system knows what to do with it. You no longer have to worry about that internally to the system. The only change that you might make is you would have different rules that you want to use to evaluate a different kind of message. But still, that is something that Tazama is modular and extensible in its design so that it can handle new rules all of the time anyway. So you will be deploying new rules that handles your new message, but this part is now sort of taken care of, right? We've solved the problem of having to build your own interface in code. The challenge we have is this problem here, right? So in our system, we use NATs as our inter-services communication mechanism. And previously, as part of our performance improvement project, we had implemented protobuf to be able to transmit messages as efficiently as possible between all of our different services. Now, for protobuf to be able to work effectively, what you need to do is you need to almost strictly type and buddy, please stop me from butchering this if you can see me going completely awry, right? But essentially in the serialization and the deserialization process, you have to use a TypeScript interface, which is a strictly typed object to help you with the translation of your message from internal code format as a JSON object into something that can be transmitted via protobuf. And then you have to reverse that process on the other side. So typically what would then happen is if I wanted to change the messages that I'm sending across the system, I need to create new interfaces that can host that message. Because if there's no interface available, protobuf can't actually do, or the TypeScript code in protobuf can't do the encoding and the decoding effectively. Foley, please help.
Just to correct you there, the requirement for protobuf is actually a proto file, which is a
Yes.
strictly typed file that is required. The TypeScript interfaces that we are making use in the platform is not a requirement. That's simply an ease of use thing to say I'm sending this proto file across the wire, and on the other side, since I know it's a proto file and it's going to be this format, I convert that into a TypeScript file that I can use easier in code. But the TypeScript piece is optional. It's not a requirement, but the proto file, the strongly typed file, is a requirement. So the essence of the problem is the same.
Right. And that is a problem that we currently have, because if we are adding new file formats or message formats here in this dynamic service API, protobuf doesn't really have the ability to effectively traffic and translate them. So the only way to really do that is to almost turn them into blind objects, where the object itself is untyped. And this is something that we don't currently know how we are going to resolve this. And I don't know. I mean, if you receive the document and you review the document and you have any ideas about how we might approach this problem, we would very much like to hear from you. This is a technical issue that we would very much like to solve, because it does kind of impact our ability to create this dynamic API, because now we have a problem transmitting that dynamic message across the rest of the system. Does that make sense, more or less? Everybody
It
understands
does,
what the problem is?
except protobuf is supposed to be language agnostic, right?
Yes.
And what I'm looking at, it's more the type system, and also what I'm looking at is a new E-ES version of prototype, or protobuf, excuse me, that deals specifically with TypeScript and JavaScript. So I guess I'm suggesting that we look at this a little bit more, because in particular the protobuf-ES deals with the whole TypeScript issue and Bergson node, etc.
Yeah.
And that was just before our time. It didn't exist before then. So we need to take a look at that and see if that helps.
Cool. Thank you. Is it worth us creating a working group for this? Or do we, I almost feel like if we can maybe just have everybody have a look at the document and review it first, then we can come back and decide whether a working group would be useful for this. I always feel like that might be a better process, but happy to take feedback from the floor.
Well, initial thoughts is that you can make your proto file accept a optional string, and that string is your encoded source object. So in your proto file, you can add a random string object, and that string object will be your encoded original object. And
Right.
then at the event director level, when it reaches there, it is only interested in the transaction type, which is a requirement. And then it wouldn't need to deserialize that string object of unknown, but then it can flow through the system.
Right. And then the only component that really needs to look at that message to understand the content is the rule processor. And the
Yeah,
assumption
so
is the
what
rule
about
processor.
size? We
Yeah.
need to make sure size doesn't impact that. But yeah, that's a good way of handling.
Yeah.
It's not an
Do
efficient
we?
way, though. It defies the whole point of using protobuf. But
Well, that was my next
well,
question, right? How
yeah,
much of the?
it's basically what I'm saying fully is it does. And that works better with the binary format like Burbuff,
Yeah.
or its own binary format.
Mm.
So, yeah.
Okay. Okay. Uh, Thank you. Um, let's come back to that. So if you have an opportunity to review the entire document in context, then, but yes, that is one way that we might be able to do that. But as you say, we are then giving up the benefit of protobuf in the first place.
Yeah. I'm
Okay.
all for working group to figure out the best way to do this. This one that the working group could look at the Burbuff-ES version, which it looks like it does with it natively. You know, they made a specific version because they realized that, you know, the TypeScript and JavaScript people are used to a much better way. It's got some companion objects that you need as well. They're installed into Node, but I suggest that's looked at.
Mm. Okay, awesome. And I think this is my last slide here. So I'm going to post the link to the document in the TSC Slack channel. This document is shared for comment, but you won't be able to edit it. If you do have any issues accessing the document, or if you would like to talk about the document in the meantime, please just let me know. Let me just quickly make sure that it's opening on my side.
can you drop that link in chat, please?
I will drop it in chat. Hey, it's working. If I can find the chat, hang on, it's over here. No, that's not the document. That's the document. Kidoki. So yes, please try that. If you can access it. If you can't, let me know. Ah, Greg, you've made it. You're in.
Yeah. Thanks.
And then this is basically the document, gives a little bit of an overview also of the plan for the ecosystem. Please forgive the rendering because this is in Google Docs, and Google Docs apparently hates Microsoft Word.
Yeah.
And all of these images are messed up. I
It
am.
happens every time, unfortunately.
Yeah. I'm going to have to paste these as actual images, so I'll do that shortly. I'll update the document. Instead of using the diagrams, I will convert these into bitmaps. That might be a little bit easier. But please review the document. If you have any comments, feedback, concerns, solutions, suggestions, please do let us know. You can comment inside the document itself as well. You can reach out to me directly. And then if we have violent disagreement on the document, it might be worth spinning this up as a working group so that we can have some robust conversations face to face. Well, virtually face to face. At the moment, any questions, comments, concerns, suggestions? Alarm, panic?
Yeah, I think it would be useful to just start off with a use case, because the use case you mentioned was that if someone is not technical and they want to be able to ingest their own data so that they can use it in a rule processor, you have to be technical to build a rule processor. So I'm I'm not following the.
I'm glad you asked. This piece here. So there is expected to be correlation between the API and the interface that you are ingesting, and ultimately also the rule builder module that we are proposing to build to help people to build their own rule processors in a low-code, no-code environment. That is currently also being specified. So that is something that we will also be reviewing at a future TSC. But the specification for this API and the message payload that you are sending through Tazama will then also be fed into the rule builder module so that you can build a rule around a specific payload that you have ingested.
Okay, that makes sense.
Cool. Thank you. And that was a very good question, a good catch. Alrighty. I have nothing else for today's agenda. Anything else from the floor? Nope. Great. Thank you very much, everybody. Have a good evening and a good day wherever you are. And please, we now have formally issued a request for comment. Please let us have it.
Thank you.
Well, thank you.
Thanks all.
Thanks, everybody. Thanks, Justice. Bye.
Bye.
Bye.